Hello, everyone, and welcome. Good morning, good afternoon, good evening, wherever you are in the world. Thank you so much for joining us today. My name is Sarah Alspaw, and I will be your webinar host coming to you from Cincinnati, Ohio, here in the U.S. I'd like to welcome you to today's webinar. Our topic, Explore New Frontiers in Aerospace and Defense with Agile Product Development. And I would like to welcome and introduce our speakers today. I will read from their bios here briefly and then quickly turn things over. With us, we have James Roche and Dale Tutt. James brings over 3 decades of experience in transforming product development and manufacturing processes. Before SimData, Roche was practice manager for CSC Consulting and Kearney, where he led the implementation of PLM offerings for aerospace, automotive, medical device, and high-tech companies around the globe. He previously served as chief architect for General Motors Worldwide Engineering Systems. Dale previously worked at the Spaceship Company as VP of Engineering and Program Management, guiding the development of spaceships for space tourism, and led a team on a successful spaceflight in December 2018. Prior, he was Chief Engineer and Program Director for Textron Aviation, Cessna Aircraft's Scorpion Jet program. In just 23 months, he led the Scorpion Jet from concept to flight. All right, well, welcome to both of you. We're very excited to have both of you here today. Jim, I'm going to go ahead and turn things over to you and make you presenter, and I will let you take it away.
And I would like to welcome everyone to today's session. We're going to be talking about agile product development in the aerospace and defense industry. Agile is a methodology famously applied to the development of software and electronic systems. For many years, there's been a movement to extend the concept of sprints and scrum masters to product development in other industries. One set of industries long considered to be immune to agile thinking. It's a little bit of a harsh statement. Some may say characterize them as the antithesis of agile, our aerospace and defense. Due to the extreme complexity of these products and the severe consequences of failure, product development in aerospace and defense has evolved into a highly structured and tightly controlled endeavor. But now this bastion of waterfall and stage gate development is giving way to agile. The transformation is being driven by customer imperatives and enabled by advances in the PLM technologies that underlie an agile development environment. We'll begin today's discussion with an examination of the drivers of this transformation and review the basics of agile and how they apply to aerospace and defense product development. Then we'll discuss at a high level the critical technical prerequisites now available to enable this transformation. At that point, the discussion will turn to exploration of a powerful industry transforming PLM solution for enabling agile product development in the aerospace and defense industry. Just a few words on SimData. For those of you who may not know us, SimData was founded in 1983 as a strategic management consulting firm totally dedicated to the advancement and productive application of PLM. With the quality of staff that we have attracted to the firm and through their experience over the decades, SimData has amassed a wealth of intellectual capital. We leverage that capacity to deliver strategic advice and counsel through a comprehensive integrated set of research, education, and consulting services. One of the unique characteristics of SimData, in addition to being solely focused on PLM, is that we do not sell PLM software or implementation services. We're technology agnostic. And when dealing with an industrial client, we are completely focused on their successful business transformation. The final point regarding SimData, one that has proven to be unique and powerful, is SimData's position within the PLM ecosystem. Providing unbiased expertise as services to industrial clients and to solution providers positions SimData as an honest broker for collaborative dialogue and action between these two communities. In 2012, SimData made the strategic decision to form an industry practice focused on strategic expansion of PLM within aerospace and defense companies, as well as its extension across their external value chains, impacting the complete product lifecycle. And I was appointed as practice director. In February 2014, representatives from 4 aerospace companies stayed over after a PLM conference in Berlin, and with the guidance of SimData, met for 2 hours to define the mission, operational guidelines, and a starter list of research topics for what on that day became the Aerospace and Defense PLM Action Group. After decades of individual action, Airbus, Boeing, Embraer, and Gulfstream decided that their common PLM pain points could best be remediated through joint action. Over the years, membership grew to as many as 11, but with dislocations in the industry over the past year, membership currently stands at 8. This association of aerospace and defense companies is chartered to work and perform as an advocacy group for the industry on topics related to PLM. Their intent is to set direction for the industry on PLM-related topics, to promote common industry PLM processes and practices, define requirements for common interest PLM-related capabilities, and communicate to the PLM solution provider community with a common voice. To form their position regarding problems, desired state, and requirements, the members, once they've identified a primary topic of interest, contribute to the research and joint projects to research and define these solutions and positions, which they then communicate to the solution providers. The PLM Action Group members have adopted a position of collaboration with the solution providers. They view the solution providers as colleagues in a common cause, and that is to improve performance and capability and value received from PLM solutions within the industrial company implementations. And with that perspective, they defined a 4-step process for engagement. The first step is, once a problem has been identified and prioritized by the members, they signal their intention to the solution providers and invite them to engage in research to identify the root causes and further define the problem that's to be addressed. In the second stage, the members invest in research to further analyze the root causes, define a desired future state. And again, they work collaboratively with the solution providers. In the third stage, the members define in detail the desired future state, the requirements by which that state can be achieved, and use cases that represent the requirements. And again, this is done in collaboration with the solution providers. Step 4, which is to formally implement these requirements within procurement documentation, is left to the members individually, as it would violate the charter and the antitrust framework of the PLM Action Group. Over the years, the A&D PLM Action Group has funded and staffed multiple project work streams, resulting in publication of research reports, direction statements, and position papers. Most recently, the group reported on a year-long collaborative effort with leading solution providers, including Siemens DIS, to benchmark the capability of commercially available technology to satisfy the multi-view bill of material requirements they had defined. The subject report documents the definition of use cases that encapsulate requirements for multi-view BOM management within an aerospace OEM, and the findings and conclusions from evaluation of the capability of 4 commercially available PLM software solutions to fulfill those requirements. The benchmark evaluation was culmination of 3 years of effort and publication of a comprehensive position paper and supporting documents. These publications and others have been released to the public and are available to you for download at the website shown here on the screen. Let's begin our discussion of agile product development in the aerospace and defense industry with a review of the relevant characteristics of aircraft and weapon systems. As we mentioned in the introduction, A&D products and systems are extremely complex, have long service lives, and must function in a wide range of often harsh environments. These products and systems generally push the boundaries of available technology and design. Many A&D products and systems are highly regulated, falling under the aegis of either authorities or other regulatory safety bodies or certification organizations. There are another set of requirements having to do with protection of intellectual property and regulations regarding the export of technology that must be adhered to. And a final overriding consideration is that any product failure in these industries could lead to catastrophic consequences. These product characteristics result in serious development challenges. As a result, development cycles have tended to be formal and lengthy, and most programs use a phase gate approach in a waterfall development paradigm. However, during these extended product development cycles, functional requirements and the available technology that could be embodied in the products can change. And this presents a dilemma to the development organization. It introduces the potential for the need to go through a reset and repeat of the product development process, or accepting a suboptimal product design as the outcome. With this approach, it's difficult to incorporate new capabilities and technology once the program go has been issued. And adjusting requirements and/or changing the solution technology during development further increases the overall program time and cost. These challenges have, over the decades, generated increasing pressure for substantive change in the fundamental product development paradigm. There have been significant improvements, major advances in integrated product development, system engineering, total cost of ownership analysis, and advancements in program management techniques, earned value management, critical path and critical change, in the application of artificial intelligence analysis of program performance metrics. All of these innovations have been improvements, but they have not kept pace with the increasing demands for more capability and hence greater complexity of the products. The increase in A&D product development costs and lead times has been relentless, despite these improvements. One major entity in the A&D ecosystem is determined to break this pattern. The United States Department of Defense has issued the challenge, and the military branches are putting it into their contracts for weapon systems acquisition. The goal has been set: incremental development and order of magnitude faster development. These goals are seen as imperatives in the competition with other global powers. It is our belief within SimData that just as California emission standards set the baseline for the global automotive industry, this imperative, as declared by the United States Department of Defense, could be powerful enough driver to change product development across all of A&D. The framework is in place, but the details of how this will be executed are still to be defined. The reference at the bottom of this slide would be an excellent first read for those of interest in this topic. As mentioned previously, Agile has long been well established for software development. Historically, Agile is a group of software development methodologies based on the definition that crystallized with the release of the Agile Manifesto, referenced here. The core values of Agile are in stark contrast to the traditional approach of waterfall and stage gate. It places individuals and interactions in priority over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. In a single statement, at the core of Agile, it's about doing the right thing, not doing things completely right. The main features of Agile development are listed here. Development is executed iteratively as a series of cycles, beginning with a subset of the total requirements. A focused team designs, builds, tests a solution to meet those requirements in a burst of activity over a period of weeks. And the team delivers a tangible portion of the total solution as their outcome. With repetition of the cycle, the solution is developed and delivered and may be deployed incrementally. The next three characteristics are consequences of the first two. Developing in cyclical sprints allows for incremental learning and rapid adjustments in response to changing requirements and advances in technical options. That means avoiding starting over or massive redevelopment. And that means reduced cost and overall time of development. The figure on this slide illustrates the iterative and incremental features of the Agile approach versus the waterfall approach to product development. A critical aspect of Agile is the ability to fully execute each of the sprint steps shown: define, design, develop, or build, in the case of a mechanical product, and test, or verify that the design meets the requirements. One reason why Agile has been applied so successfully to software development is the ability to carry out all of these steps efficiently and effectively. In many companies, the sequence of steps from design to develop to test are highly automated. Carrying out these steps from design to build to test for mechanical or electromechanical products traditionally involves construction and testing of physical prototypes. This is not something that can be done within a process construct of sprints. A new approach for executing the design to build to test cycle is needed. The breakthrough for application of Agile methods to the mechanical domain came with the advent of the digital twin. Using the digital twin, complemented with simulation technologies, enables Agile teams to quickly identify and evaluate design options, thus shortening their decision and sprint development time while reducing risk. This capability has long been available for software, but now physics-based digital twins provide this capability for mechanical and electrical domains. Having a digital thread provides Agile development teams with access to all the information they need to use as part of their individual sprints or scrums. Digital twins for product design, for product manufacture, and for in-field operation, linked by a digital thread, enable lifecycle performance verification during product development sprints. These changes, these capabilities are truly transformational. Another key aspect of the digital twin and the digital thread within an Agile paradigm results in all personnel involved in the development process having broader information access, so they are less specialized in their thinking and more aware of interdependencies with other disciplines. For decades, the concept of concurrent engineering, integrated product development teams have been pursued with mixed results. Great successes, yes, but not total success. But with the linkages and the information sharing and the information access available through digital twin and digital thread, the ultimate vision of concurrent engineering, integrated product development can become reality. Application of agile methods to product development in aerospace and defense can transform a company's performance in the market. Responsiveness to shifts in mission requirements and advances in technical options, cost and time to market. But to harvest these benefits, a company must transform internally as well. Not only must new processes and technologies be implemented, but the company's foundational culture must change as well. The good news is that the needed transformation will have a positive impact and once understood will be welcomed by the workforce. As we mentioned earlier, Agile prioritizes the individual within the development team and their interactions, putting them above the tools and processes they use. With Agile, collaboration is given more emphasis as members of the product development team put their heads together to solve problems. Personnel or people empowerment is prioritized. Members of the team feel more motivated when they feel that they are working with other people in the team instead of for a person of authority. And self-organization is greatly encouraged, and all of the innovation and invention that comes from that is encouraged in a product development environment that follows the Agile methodology. So this model is very much compatible with the new social way of working. And in fact, we see this in startup companies in aerospace and defense. So if you want to look for successes of Agile in aerospace and defense, you look to the startups. And what we're starting to see now is a permeation of these concepts within the more established and larger organizations within the industry. Respondents from a range of industries to a recent survey by Organize Agile published by Consultancy EU cited several benefits as shown in this chart. This will be good information for you in your own personal assessment and perhaps some good ammunition for you to use with colleagues and people in decision authority within your organization. In summary, Agile product development is the future for our aerospace and defense. It's not a question of whether this will happen, but a question of when. A&D products, as we've noted, have become ever more complex, with requirements and technology evolving faster than traditional serial development processes can be executed. This is the primary driver. This is the primary constraint and the primary opportunity. We are postulating that the U.S. Department of Defense decision to move to a new acquisition model that will require A&D companies to deliver solutions faster and with a constant construct of validated modules will be the impetus to motivate this transition. And finally, moving to an agile development environment will require aerospace and defense manufacturers to transform their product development lifecycle to empower the agile development teams with capability to define, model, simulate digital twins of the products they are developing and adopt the culture that matches the method. I hope you found this portion of today's webinar to be informative, and I look forward to interacting with you later during the Q&A. Now I'll pass the ball to my colleague, Dale Tutt.
All right, thank you, Jim. I'll share my screen real quickly. All right. Let's see. All right. Well, thank you I want to thank everyone for joining us today as we talk about Agile product development. And I'm going to talk to you a little about Siemens solutions around product design engineering industry level solutions. Sorry. So we're in a period of probably the greatest innovation that I can remember in our lifetime, and there are so many interesting projects going on and so many startups. We're seeing innovation in urban air mobility, where we're seeing hundreds of companies working on air taxis that will be really transforming how we travel about these large urban areas. And these are all most all of these are electrically powered, and it's companies big and small. We're seeing innovation in defense, and around the world, we're seeing new fighters being developed. Whether it's in Europe with the UK Tempest program, or in France, or in Asia, or in the US, we're seeing these new fighter programs starting. And what they're all trying to do is achieve sixth generation capability, but oftentimes at half the cost and at half the schedule of the previous generation of fighter aircraft, which is really transformational when you think about how these programs have the length of the programs and the cost of the programs has continued to increase over time. We're seeing innovation in space, again, where hundreds of companies are working on new space launchers, satellites, explorations, even space tourism. And it's companies big and small. The space is no longer the domain of large companies and big governments, but it's really becoming the domain of startups and new entrants into the market space that are really transforming how our access to space. With all this innovation, and we're now entering, we're now in the digital era. For companies to really survive and thrive in this digital era, they need to become digital enterprises. They need to rethink every element of their business. To achieve business transformation, they have to have digital transformation. So at Siemens, as we work with companies in all of these different segments, air taxis, defense aircraft, space systems, commercial aircraft, what we're seeing is some consistent trends across all of these subsegments. So there's a pressure to get to market faster with new capabilities, with new products faster than everyone else. So there's this pressure to reduce their program cost and schedule. We're seeing increasing program complexity and integration of all of these new systems. With all this innovation going on, how they are achieving the performance objectives is they're integrating more and more of their systems together. They're taking weight out, and they're using more software. And this is increasing the challenges on cost and schedule. We're seeing increased electrification of products, and it's not just electric propulsion, which is part of decarbonizing the aviation industry, but it's really about also improving the performance of their systems, the reliability and sustainability. So you're seeing mechanical systems being replaced with electromechanical systems. And then finally, we're seeing globalization, whether it's your supply chain or your own workforce. We're seeing this need to collaborate with your partners and your team members all around the globe. And maybe this is maybe exacerbated by the global pandemic, where more and more people are now working remotely, and that's put even more pressure on the need for better collaboration tools. With all of this innovation, with all these challenges, we're seeing this explosion of complexity. And some companies, they will seek to simplify, they'll try to reduce the complexity in order to manage their risk. But what we're seeing is that the companies that are truly transformational are embracing the complexity. They're using digital transformation to help tame that complexity. And as a result, they're developing higher performing products at lower cost and faster than their competitors. Now, how are they doing that? The keys to the competitive advantage that they are using is, first, they're using a comprehensive digital twin. They're using the digital twin to have a much more robust and rich understanding of how the product is going to perform, how you're going to build it, and then how you're going to support it once it's out in the field. They're using personalized, adaptable, modern solutions. The ability to use configurable out-of-the-box solutions so they can deploy them faster and get benefit from them faster, but they can also be easily tailored to meet the needs of their program so that they can have competitive advantage. And finally, and probably the most important thing, is to be working in a truly flexible and open ecosystem. To be able to bring any solution into your process that helps you succeed in developing your products faster, but also to be able to use maybe legacy solutions that you've had and have had very much success with, that you're now able to incorporate those more quickly into your flexible and open ecosystem. And then finally, this technology is always advancing. And as you're bringing new technology, you want to be able to leverage that faster. Again, you're going to be able to implement it into a flexible and open ecosystem much faster. And so it really is one of the keys to competitive advantage for the companies that are really succeeding. At Siemens, we've grouped all of our solutions and our services offerings and into the accelerator portfolio. And this scales for companies big and small. So a company of any size, we can partner with them to help them on their path toward digital transformation. This is really bringing the future solutions, making them available today. Part of the accelerator portfolio are these industry solutions that we call our aerospace and defense digital threads. And these solutions are really geared towards solving complex business problems to help companies generate program execution excellence. And so they're organized among 5 functional areas that account for probably 95% of the people that are working in any program. So engineering and program management, supply chain, production, and product support. And as part of the engineering function, today we're going to be talking about the product design and engineering digital thread. But these digital threads are really about helping with the automating the data transitions between different solutions to be able to help automate workflows and streamline workflows so that companies can work together faster, have more transparency in their processes, and your team members can focus on instead of focusing on administrative tasks such as translating data, that they're able to focus on actually solving complex problems. The previous slide might have indicated that these are serial activities, serial processes, but when you think about a generic program timeline moving from concept design into design and then testing and serve into production, what you see is that these digital threads actually cover the entire product lifecycle for any future for any new program. And these horizontal threads, these digital threads, they're also interconnected. So there's interrelationships between all of these threads. As is indicated on this chart, where you see with product design, you're really bringing in all of the digital threads and activities related to all the digital threads. That really these vertical interconnections create this fabric of this digital fabric so that you have total transparency within your program. But focusing on the product design and engineering digital thread, again, it's a full lifecycle product. Full lifecycle digital thread. And as you see, as you go through the program, that there's different tasks and solutions along the way that you're trying to solve. So in conceptual design, maybe you're looking at doing multidisciplinary optimization, system simulation. Then as you move through the rest of the program, the design changes, the design functions change a little bit. You get into more executing a design and then implementing changes as a result of test and production. But these are the tasks, and this is how we map some of these tasks to these digital threads. And now I'm going to show a quick video on the product design engineering digital thread, and hopefully it'll explain this a little bit.
Nature is an amazing engineer. Beautiful, fast, efficient, and agile. Extremely agile. It's about maximizing agility, minimizing risk, creating a flawless design. Nature sparks our curiosity with endless possibilities and incredible innovation for flying machines. Just as nature evolves to deliver flawless products, aerospace and defense companies must transform their engineering processes. Companies need modern, open, and integrated design ecosystems, leveraging the comprehensive digital twin and digital thread to boost innovation, reduce costs, technical risks, and design cycle time. Using Agile methodology and the power of digitalization, define a program plan that accelerates product development. Build a collaborative, model-based design environment, combining electrical, mechanical, and software disciplines to foster iterative and innovative designs, using virtual verification and manufacturing to test the designs. Employ next-generation, simulation-driven design to capture intent to facilitate downstream activities for testing, manufacturing, and service. Collaborate with supply chain partners, no matter where they are or what design tools they use. Rapidly meet requirements in each sprint, always testing, verifying, and validating to mature complex programs faster. Fly your designs before you build them. Use the latest visual technology to design for manufacturability and supportability. Simulate and analyze factory and manufacturing methods in real time, including in-service tasks. Maximize agility, minimize risk, flawless design. Excel at agile engineering and program execution with the product design and engineering digital thread for aerospace and defense. Siemens, where today meets tomorrow.
All right. Thank you, and I hope hopefully you enjoyed that video. But the rest of my presentation, I'll go into some of the details and discuss the topics in that video just a little bit more. So when we look at the challenges of the future of flight, in this case, we're talking about an air taxi, but we could be talking about a supersonic aircraft or defense aircraft, and the innovations that are brought about in some of those other, other types of aircraft. You see the innovation increasing risk and impacting the development process. But in the case of an air taxi like this, you're thinking about your power density and how do you incorporate your electrical propulsion system and manage all of the heat loads from all of the electrical systems on the aircraft and the batteries, and integrating all these systems together, including automated flight. And then how do you move through verification and certification while providing a safe and comfortable passenger experience, and many more challenges in addition to this with aerostructures and with the aerodynamic design of the vehicles. So there's a lot of challenges, and how do you work through that? Well, in order to go quickly, you start thinking about Agile and moving from the legacy processes, as Jim was talking about. And so when you start to go Agile, what you're looking at doing is, sometimes people think, well, Agile, it's kind of chaotic, and they see it that way. But my perception is that it's a very structured program planning. You really have to do a good job of program planning up front that helps you build in the flexibility that you're going to need as you go through your program quickly and be able to incorporate changes. And it breaks it down into sprints with an executable scope to iteratively mature the project. On some of the projects that I used to work in the past, that we called it chunk management. Actually, this week you'd work on the wing chunk, and the next week you'd work on the tail chunk, and the week after the fuselage chunk. And we broke the program down because we had a small team, but we wanted everybody to be focused, say, on the wing for a week and working on the systems, the structures, and to help mature the entire wing at the same time. And so we'd have these very focused teams working on this section of the airplane. Next week, maybe we'd work on the next section, but it was very successful in being able to help get the maturity of the product to the same point quickly. There's very much a customer focus so that you can easily incorporate new capabilities and new requested changes. As Jim mentioned, these products have long life cycles, and the technology is changing sometimes quicker than the program can be executed. You need to be able to be flexible to that. You need to be able to minimize and effectively manage the change, especially as you start to build your product. And then, one of the objectives is to have earlier risk mitigation and faster learning cycles, especially as you go through the development and certification process. So in going Agile, you really are trying to transform your product development processes. It's not just about the technology, but there's also process and cultural change that has to go with this. But the goal here is to really increase your flexibility to meet the evolving customer needs as well as all the market forces, and to be able to tap into the full potential of your workforce talent so that they are feeling empowered and that they can work and expand their skills and be involved in more of the decision making. You want to dissolve those disruptive silos that are preventing you from getting the work done, and doing this in a way by how you're organizing your teams. And then finally, transforming your program management processes to focus maybe less on milestone achievement, but more on the plan that will develop and deliver more mature content. So what does this look like? What's an example of this? So when we keep talking about the digital transformation, the digital twin is enabling agile product development. Well, what does that mean? So when we talk about software, a lot of times people say, well, it's easy to do software because agile with software because you don't have to build anything. It's harder because we have to build stuff. So what's a way you can do this with using digital tools? Well, one way is as you develop your initial program plan, you break down your program into these chunks, into the sprints. You do your sprint planning for each sprint. You conduct a number of sprints, and that's what you need to get to rig testing. And then from your rig testing and from what you've learned, you have some changes. Maybe you've had some new customer requirements come in. And so now you need to be able to understand how to incorporate those into the future sprints. So you do your sprint planning for your future sprints, and you get to the point where you build your prototypes. And then beyond that, maybe you have some additional sprints that actually helps you complete the program, and now you start your build processes. And so throughout the entire process, you're increasing your product maturity and the capabilities of your product. And as you go forward from this, you're now adding more, you can now add more capabilities to your product. But throughout the entire process, you're doing continuous integration, you're doing continuous program management and verification of all your processes. So in using the digital twin to enable these engineering sprints, what you do is for each sprint, you have a sprint plan. You decide what you need to do. You understand the requirements of that sprint. You complete your design, your mechanical, software, electrical system designs. And then you use the digital twin to do virtual verification. I'll talk about this in a couple slides a little bit more, but you're able to verify the performance of your product at this point in time based on the work that you've completed so far. And you start to do virtual manufacturing, using those manufacturing simulations to demonstrate that you're going to be able to build the product, that you have confidence that you not only have a product that will perform well, but also that you can build it. And then you deliver the sprint. And the output of each sprint is actionable output that can now be rolled into the product baseline, and that definition is now ready to be used for the next sprint. So this is how you start to build that foundation, but you're really leveraging the digital tools that you have. And over time, as the digital twin, as your product matures, your digital twin will mature along with it, and you'll get more and more granularity on it. So in addition to how you're changing your processes, what are some of the other things, the other solutions within this digital thread that help you accelerate your innovation? It's things like advanced design analysis solution, multidisciplinary design optimization throughout the entire process, using a virtual integrated aircraft to verify your product in a collaborative design environment, in a flexible and open PLM system. And then finally, providing advanced user experiences. And I'll talk about these on the next couple slides. Well, for example, advanced design and analysis solution. It's things like your integrated electrical and electronic system design and bringing in advanced CAE and simulation to help you design the product better, to help drive the design of your product, but to also help verify your product and the performance of your product. Bringing solutions for integrated mechanical system design that couple your analysis and your simulation with your mechanical design tools. Being able to bring in advanced materials, both from a design analysis standpoint. Composites are still a big part of a lot of our aerospace and defense solutions today, and they're going to continue to be in the future. So be able to have tools that enable you to design those efficiently and effectively and manufacture them, but also additive engineering, which is a growing area within aerospace and defense, and it's going to become a bigger and bigger part of aerospace over the next 8 to 10 years. Bringing integrated aerostructure solutions that really go from the loads into the structural design, the structural analysis, as well as the flutter analysis that provide that digital thread even within your aerostructures design. Using generative design and topology optimization so that you can design your products faster, integrating simulation with your requirements as well as with your design tools. And then finally, using artificial intelligence and machine learning to help all of your tools, to help automate more of your processes and help you go faster. When we talk about multidisciplinary design optimizations, it's really intended to help develop better designs faster. So it's much more than 3D CAD when you're designing these kinds of products. But you bring your 3D CAD with, say, in this case of a landing gear, your hydraulics design, your controls design, you're doing your motion and stress analysis, and you're developing your loads using CFD. And the output of this process, it can be very iterative, and maybe you go through hundreds of iterations to finally optimize the design. We have some great examples of customers that have successfully taken a lot of weight out of their their landing gear system using these solutions. But you develop the digital twin of your design, and then you go produce the real product. Virtual integrated aircraft. This really leverages the digital twin to the fullest extent. You're able to do this because you have this rich understanding of your system performance. You understand how the system's going to work, and you're able to use a lot of out-of-the-box solutions to help go faster. The goal here is to fly it before you build it, to make sure that you understand how it's going to perform once it's out in the field. And the real benefit here is it really leads to more effective test programs with less risk, because you're identifying changes before you start building any parts. You're able to identify those issues sooner and correct them, so that once you move into your test program, you're at much less risk for changes. And you're also able to make your test programs much more effective, and because you're able to focus only on the most critical parts of this. And we have customers that are using these types of solutions, and they're reducing their physical test program by 25 to 30%, really transforming their business. When you think about the amount of money that a company invests in physical testing of their products, that can be a pretty huge time and cost savings. When we talk about the collaborative multidisciplinary design environment, it's really about having a collaboration platform that enables all of the users and all the different functions to really be able to collaborate together, to know that they're all working on the same configuration. So you have the configuration control. And this collaboration platform really provides this authoritative source of truth that enables you to know that you're always working on the latest data, and you have visibility in any changes that are being made. So regardless of what functional area you're in within the design of a product, that you're able to communicate and collaborate effectively with each other, having a very robust configuration management control. I mentioned, we've talked a little bit about the flexible and open PLM platform and open ecosystem already. But this is, the purpose here is to really bring you a true multi-CAD, multi-tool environment, so that you're able to consume information and data from any of your suppliers, any of your partners, and that you're able to, instead of pushing, your CAD solutions down to your suppliers and adding cost to their solutions, you're able to help minimize the overall cost of your entire partner ecosystem. This is very open to legacy solutions. You're able to maximize your collaboration among your team all around the globe. Again, we talked about this already, about this robust configuration and management and change control, and really having that authoritative source of truth to know what the configuration of your product is throughout the entire product lifecycle. Finally, advanced users experiences, and this is really about how do your team members interact with the solutions, and providing this immersive 3D environment and being able to design in context with virtual reality, so that the engineer is now looking at parts and they're designing in context. They're looking at these parts much the same way that a mechanic or a technician might look at them. You start conducting virtual design reviews. You start automating some of these workflows so that your users are able to focus their time on doing their design engineering activity. And then finally, bringing new solutions even in at the level of predictive commands, so that the system starts to learn how a particular user is using the system on a consistent basis, and it starts making recommendations around commands. And even though this seems kind of small, when you think about the number of operations that a user might go through to design a system or a part or analyze it, these time savings can really start to add up over time, and it just generally creates a much better user experience. So digital transformation really enables this agile product development, and again, the key elements of agile product development. So as we bring these tools for innovation that I just talked about back into the context of agile product development, it really is about helping you plan executable scope elements, using incremental deliveries to mature your product, and really burning down your risk using the virtual testing and manufacturing so that you're learning about your products faster. And then finally, managing your configuration on a robust PLM digital thread for your process. And we have a couple examples of some companies that are using solutions like this today. In case of Agile Aerospace, we've done some case studies with them, and they've talked about how they're linking all of their solutions together and their analysis together, and they're using a lot of their parametric designs, and in some cases they've seen, as they've looked at new configurations, that they're seeing like 60% reduction in some of their engineering hours. They're seeing these dramatic improvements, or seeing dramatically faster results as they develop new configurations of the vehicle, because they're able to leverage more of the data from the previous solutions, and they're able to use more automations. And Boeing is another great example, and they've been in the news quite a bit lately with the work that they did, being the first platform for the U.S. Air Force. Jim talked about the new digital acquisition processes, and they truly bent the cost curve. They actually probably broke the cost curve, because they won this program for a lot less money than what the Air Force expected, and they did this through digital engineering, and they saw great improvements in their model-based engineering. With first pass quality. They saw improvements on their manufacturing side, where they're actually starting to take a lot of cost out. 80% reduction in assembly hours. I think the article that I got a lot of these, that we got a lot of these figures from, that talked about their digital engineering processes, really, also talked about, that, they went from 24 hours to like 30 minutes on some of their splices. And so it's really transformational results when you have a fully, fully developed digital enterprise. So in closing, we really want to help you go agile with your product design engineering solutions, to be able to go faster and innovate more, to be much more flexible to changes as they come, to be able to improve your collaboration within your team and your supply chain. And in doing so, you're transforming your program management processes so that you are maturing your products faster while minimizing risk. And so with that, I will say thank you very much and appreciate your time today.
And this concludes today's webinar. Thank you so much for joining us, everyone, and have a great rest of your day.